So today what we're going to look at now is using those notes that we just looked at, how we can take a function, it's essentially its parent function, and then do the transformation. So we could make a table of values. We can do that for any of them. But making sure that we get key features of the graph, what is best is if we take the parent function, make its table and graph it, and then change the function around. So if we have, let's say for our first example, and so what I've got here is f of x equals 2 to the x. So I've already got its table of values and its graph. We used this in our examples Monday. And so we're going to use that and look at some different examples. All right, so we want to look at how does this example change from this one. So we have plus 1 and it's in the exponent. So plus 1 in the exponent is here, so that means that's a horizontal shift. So that's how many units we're going to move it to the left. So we're going to move this to the left 1 unit. So since I already have this as my parent function, all I'm going to do is I'm going to take all of these points here and move them to the left 1. So I could do that on this graph with it, or I could do it down here. I'm going to try to do it down here so they don't overlap so much. So I just took every one of these points and I moved them to the left 1. And you can do it on the same graph if you'd like, or one below it. I just didn't want it to overlap and look confusing. Now remember, this has an asymptote of the x-axis here. And we didn't move it up or down anywhere, so that still gets closer and closer and closer to the x-axis but never touches it. So what are some things that changed here? Okay, domain is still the same, negative infinity to infinity. The horizontal asymptote still is the same. It's both the x-axis. This is getting closer and closer to the x-axis but doesn't touch it. So the range didn't change, so that would be 0 to infinity with parentheses. But what did change here, I can see, is the y-intercept. So here the y-intercept was 0, 1. Here the y-intercept was 0, 2. So I can see that was a change of a characteristic there. All right, let's look at another example. So let's look at how this differs. Okay, so here, let's put a plus here. So this plus 1 was adding to the x. So that moved that left that many units. This plus 1 is to the whole function on the outside, so that's moving it up that many units. So that's taking and moving these all up 1 unit. So I could do it on the same graph, or I could just look at them and move them up 1. So we took this graph and we just shifted it up 1 unit. So same thing is still happening here. All those points are the same, but here we can see instead of getting closer and closer and closer to the x-axis, this is now getting closer and closer and closer to the line y equals 1. So now the new horizontal asymptote here is y equals 1. So this is the line that it's getting closer and closer and closer to but doesn't actually touch. It did also change the y-intercept from 0, 1 to 0, 2. Domain is still the same. The range would change. It would be from 1 to infinity with parentheses. Okay, and now let's look at one more example. Alright, so this negative here that is on the outside means that it's going to reflect it over the x-axis. So this is the x-axis, so it's going to flip it this way. So what was above the x-axis will now be below the x-axis. So like this point was 0, 1, it would be 0, negative 1. So I'm just flipping those points over. This one that's at 2, 4 would be 2, negative 4. And so it's going to look like that. So horizontal asymptote is still the same at the x-axis. Domain is still negative infinity to infinity, but now range is negative infinity to 0 with parentheses. And the y-intercept went from 0, 1 to 0, negative 1. So that would be a change there. So what we're going to look at today is graphing a parent function like this, and then being able to describe what is happening to that graph and what should it look like. I'm not going to actually make you plot any of those that make it steeper or less steep, but I do want you to be able to recognize it on like a multiple choice question, how that would make it steeper or less steep. So if I were taking this function and doing like that, should make that steeper. So steeper is going to be like this, where it's going to be steeper like that. And then if I gave you like this, that's going to make it less steep. So it's going to make a curve that's out here like this, that's less steep. I'm not going to make you actually plot those, but I do want you, just like I did before, but I do want you to be able to recognize them at this point. Later on, we will graph them and make some tables with them, but for now I just want you to be able to peek out that this made it steeper and what steeper looks like, and less steep and what that looks like. So if you have any questions for today's assignment and tomorrow's, then just send me a message. Love you all and miss you all. Bye.